At this scale, the Earth takes on a biological appearance. These channels resemble the branching bronchial tubes of a lung or a feathered wing. These formations are entirely geological. Gravity and water carve these channels into the silt through the simple pursuit of the path of least resistance. Geologists classify this as a dendritic drainage pattern. The name is derived from the Greek word dendritis, which means tree-like. This is the most common drainage pattern found in nature. It appears across the globe in vastly different environments, from coastal tidal flats to dry, hilly landscapes. This raises a question: how does unthinking water, without a blueprint, consistently carve the same efficient shapes into the earth? This pattern requires specific physical conditions to form, starting with a uniform material. The soil, such as riverbed silt or mud, must have a highly consistent texture. In rocky terrain, hard obstacles force water to divert and create irregular paths. But on a smooth, uniform surface, the fluid is guided solely by gravity. The process begins as a retreating tide pulls a thin sheet of water back across the mud. As the water recedes, it breaks down into tiny finger trickles that move downward toward lower elevation. These individual trickles eventually merge. As they combine, they cut deeper grooves into the sediment, creating a permanent path for more water to follow. The network isn't designed from the top down. It builds itself from the bottom up as individual streams find one another and form a unified system. This tree-like structure is the most efficient way to move fluid across a wide surface area. In a dendritic system, the smaller tributaries join the main channel at acute angles, less than 90 degrees. Merging at a shallow angle preserves forward momentum. The volume of the water increases, but the flow never has to fight against itself to keep moving forward. This creates a fractal, a geometric pattern that repeats its structure at every possible scale. If you zoom in on one tiny feather at the edge of the mudflat, you will see that it is structurally identical to the massive drainage system it belongs to. These geometric rules ensure that fluid is transported as quickly as possible, whether the channel is an inch wide or a mile long. Because this geometry is so efficient, we see it appearing in places that have nothing to do with dirt and water. You can find this exact shape in the internal veins of deciduous leaves. Plants utilize this layout because it is the optimal way to distribute nutrients across the surface of the leaf with the least amount of energy. Human anatomy follows the same blueprint. Our neural pathways and our blood vessels branch out in these same patterns. Our survival depends on this acute angle branching to move blood and electrical signals rapidly without losing momentum. We even see it in meteorology. As a lightning bolt seeks the ground, it branches downward through the sky. Electricity moving through the atmosphere follows the same path of least resistance logic as water moving through mud. Whether it is carving continents, circulating blood to the brain, or striking from the sky, the laws of physics rely on this single, efficient geometric shortcut.